Hi, this is Ms. Fitzmaurice. This is your second Physics P video, and there are a few things that you're going to get out of this video. So this video is going to talk about motion basics. And so what you should get out of this video are some key terms and symbols, some examples of types of motion, okay, and then lastly, I want you to be able to distinguish between some similar terms. Okay, so as I said, the first thing I'm going to do is I'm going to give you some terms. So what I need you to do is copy down this chart. Okay, so the first term, and you probably even used this word today in class, is position. Okay, so for example, if your little buggy car was moving along and you made little marks on the table, then the position is just how far the buggy is from the start of your ruler. Okay? Okay, so in physics, we are going to use an X for position. Okay, and the basic meaning is where an object is. Or where it is located. Okay, so the second term is initial position. And what that basically is initial means beginning, so it's where an object started. Okay, and because it's position, we're going to use an X, but to signify that it's the initial position, you're going to put a little 0 underneath the X. And actually, anytime you see this little 0 in physics underneath something, it means initial or beginning. Okay, so the next term, and you may or may not have heard of this one, is called displacement. And it's basically a change in position. So if you are displaced, you are moved. Your position is changing. But more specifically, when we talk about change in physics, we always do the final position minus the initial position. Okay? And we also write this is the same thing. If you see delta x, it means final position minus initial position. Okay, so this triangle right here, it's called a delta, and it means change. And you may have seen that in chemistry, and I think you saw it last night when you were watching the video on slopes. Okay, so the next term is speed. Okay, the symbol for speed is V, but we have to be careful because V actually means the next term, which is velocity. Okay, so we have speed and velocity, and you might think they're the same thing. Okay, they're basically how fast something's going. Okay, they have the same symbol, so speed is how fast. Okay, or how much your position changes with time. So I could say delta x with time, because remember delta means something's changing. So delta x is change in position with time. Velocity is, again, how fast. It's the change in position with time, but it also includes direction. And what I mean by that is that if you have a little car and it's heading to the right, and you decided that in your universe to the right is positive and to the left is negative, then this car right here has a positive velocity. Okay, on the other hand, if there's a different car, and you can see my amazing artistic skills, everything I draw is a box, but they're all cars or people, okay? Since it's heading to the left towards the negative, it's going to have a negative velocity. Speed, on the other hand, it's an absolute value. Okay, so the difference between speed and velocity is that speed has direction, or speed does not have direction. Okay, so it can never be negative. Velocity, it does have a direction, and it can be either positive or negative, and not right this minute. So in a couple weeks, we're going to start talking about when it's not just to the right or to the left, positive or negative, but if your velocity is up at an angle, or up at a different angle, down at an angle. So velocity includes direction. Okay, so the last two terms we're going to talk about tonight are acceleration and delta. Okay, so acceleration. You think about acceleration of a car. When a car is accelerating, a car is speeding up. Okay, to have acceleration, something doesn't need to be necessarily speeding up. It could be slowing down. It could be starting from moving and going to stopped. But basically, what acceleration means is it's a change in velocity. And I'm just going to put V for velocity. Okay, the symbol for acceleration is A, because acceleration starts with an A. Okay, finally, delta. Okay, delta means change. And I showed you delta x. It's always a triangle, and it's always final minus initial. Okay, it could be position, it could be temperature, it could be money, it could be almost anything. So to help you remember, I'm going to say that this guy, he is changing mood, so it's his initial mood minus, his final mood minus his initial mood. I put a little 0 to indicate this is his starting mood right here. Or if you had a change of heart, it is your final heart minus your initial heart. Okay, this triangle thing, it always has to come before something else, and it always means final minus initial. Okay, so the next thing I want to do is talk about the difference between displacement and position, and I want to make sure you understand what each one is. Okay, so what I have is I've drawn SpongeBob here, and SpongeBob lives in this kind of boring world, and what I can do is I can move him back and forwards, and you notice that he lives kind of on this number line, And on this number line, we've designated meters, that's the M. He can move backwards and forwards, but he can't really do anything else. Okay, so what I'm going to do is I'm going to tell you a little story about SpongeBob's motion, and what I want you to do is I want you to tell me at the end of this, what was SpongeBob's, one second here. So what was SpongeBob's initial position, final position, and change in position? Okay, remember that this guy, the delta x, the change in position, is the same as displacement. Okay, so here's what SpongeBob does. SpongeBob starts out at his 2-meter mark. Okay, he goes for a little walk, he comes back, and he goes back and forth because he has a boring life, he has nothing better to do, and he stops at the 0. Okay, so take a second and fill in what his initial position, final position, and change in position were. Okay, so now that you've taken a moment, he started, as I said, at the 2-meter mark, so x naught is equal to 2, and I'm going to put m for meters. It's really important in physics to put our units in because there's a big difference between 2 meters and 2 inches and 2 millimeters, and we need to know which one we're talking about. Okay, even though he moved back and forth and back and forth and back and forth, his final position was 0. Okay, so from your notes you have delta x is equal to final minus initial. So we have 0 minus 2, and his displacement was negative 2 meters. Okay, the next two terms that I need you to understand the difference between are velocity and acceleration. Okay, so I'm going to ask you a question, and I keep trying to write, there we go, velocity versus acceleration. And I want you to think about the question for a second and pause the video. So this is my question. Okay, right now is SpongeBob accelerating? Okay, so during the first half, is he accelerating? During the second half, is he accelerating? And during his whole trip, is he accelerating? So take a minute, write down your answer. Okay, so remember, velocity is basically how fast, so that's like speed, with direction, and acceleration is change, so I'm going to draw this triangle thing in velocity. Okay, so what that means is that as long as SpongeBob's speed is not changing, so during the first half he was going pretty constant, he had no acceleration, so here he has no acceleration, but when he slows down and stops and then changes direction, in this moment right here, so not the whole back way, but in the moment where he slows down, stops, and turns around, that's when he has acceleration. Okay, so acceleration really is a change in velocity, and that can be just a change in direction. Okay, having seen that, I want you to try to answer this next question. So actually take a minute and write this question down. What would SpongeBob have to do to have a positive velocity and a negative acceleration? Okay, so take a minute, write the question down, and then try to write an answer down. And then once you've done that, check back with the video. Okay, so now that you've gone ahead and written down your answer, to have a positive velocity, all we need SpongeBob to be doing is we need him to be moving to the right. Okay, so this whole time he has a positive velocity. Now he has a negative velocity, now he has a positive velocity. Okay, how could he have a negative acceleration? Well, we know that acceleration is change in velocity with time. Okay, so to have a negative acceleration, we know that our positive velocity must decrease. Okay, and what that means in terms of SpongeBob's motion is that at first SpongeBob is going at a certain speed, but his velocity decreases and he comes to a stop probably. Maybe he doesn't all the way reach a stop, but the point is he's moving to the right, that's positive velocity, and he's slowing down. That's negative acceleration. Okay, so thanks for watching this video. Hopefully you have an idea of the basic terms for motion. You know what all the symbols are now. In the future, I'm going to tell you what the general units we use in physics are. And hopefully you understand the difference between position and displacement, as well as the difference between velocity and acceleration.